Now, the most important part of the this chapter that and not only this chapter, um, as you know that so chemistry is a practical area, and particular this analytical chemistry has a lots of practical that is applications point of view that compared if you compare with the theory. So lots of practical that is basis there. So that in the lab that precaution should be essential to before doing any kind of experiment. What type of precautions should be essential if you are doing any kind of experiment? So like that, if you deal with the acid, suppose let us take the deal with the acid. So that you should use your gloves. Pipetting should not be done. So lots of things that this the simple thing means precautionary that steps. And but as you customize with this field in before so many years with the chemistry, so but the analytical chemistry, as you are means going to that handle different kind of materials and also instrument. So what kind of a precaution steps should be taken, that is most essential. Neither there is an accident, there may be the accident, so be careful. So we have to that think about that safety and all the things inside the chemical lab. So that is most essential part. Okay, so experiment may be delay, but a safety may not delay. Okay, so that's why you have to take the safety precaution first, then you will do the experiment what type of things. So first thing that is what I told the initial stage. SOP must be made before doing any kind of experiment. What is the sample, what is the sample size, what is the solvent, where you have to put, what type of means instrument you will use, whether it is acid or any kind of things is there, or electrical current is there, faulty device is there or not. You have to that a standard thing you have to understand. Then only you can go for the experiment, right? Okay. So that last part of this experiment, this particular analytical chemistry, safety chemical laboratory, safety in the chemical laboratory, that is most important part. So as I told you, a laboratory is an integral component of an any scientific pursuit. Okay, so that's let us discuss. It is very honestly this fact you cannot say. Sometimes what will happen, we don't know what kind of biological metabolism is going on inside our human body. And the same that is I have seen that I am just that is going to share technical tips. So that in lab, one lab I was working in the professional life, I was working. So that chlorine gas we are means doing some experiment on the chlorine gas. Okay, so that chlorine gas has suffocating in is suffocating in nature, as well as has that some irritation towards the general context. We told you that this thing happened. Okay, on the basis of that we have taken the precaution. But what happened, one student having that asthma, severe asthma, but we are not aware about that his body capabilities and all the things. When the suffocation start, then that trigger to its the asthmatic means issues. Okay, it's triggered. So we have to immediately we have to admit it into the hospital. So what my concern is that when you are doing any kind of experiment, that we don't know what kind of a chemical is that reacting on our body, what kind of chemical is give the means what is that it is good for us, okay, no problem, no that irritation will be there on things, something like that. It's depending upon the human body even. So common what is written here over, so that is the common fact. But health issues is the fact. So you should be understand your safety first. You know that what kind of things is that associated with you. Like I gave you an example. Sometimes what happened that we put the some we hold some chemicals in our finger, or some chemicals that is some salts just toss into our finger. We don't know, unknowingly it happened. We put the hand on the that is dice, that experimental table. So some salt or some chemical touch to our finger, it is not affected to our skin. But sometimes what happens, we put our that is finger to our mouth. Sometimes it happen. So what will happen, that might be the reaction, or saliva will be there. So that you know that saliva contains different kind of that enzymes, it may trigger to that particular reactions. So my suggestion is, in the chemical lab, don't do such kind of experiments. So it is my experience, that's I am telling you, I am sharing with you all the things. So as you know that you are all customized with this analytical chemistry, you will do the practical and all the things. So after that, so whatever, then you should be careful about your first your life, then you will do the experiment. So for that you have to do one standard operation protocol. On the basis of that you have to work. So fix it, that your mind, that I should not do any kind of work that where that any complex situation will be arises. So in I few months back, so I got an information, I go through a news that is some in a school, higher secondary school, that of that West Bengal. So that that gas suffocation, that ammonia gas, they are working on ammonia gas, and due to evolution of a large quantity of ammonia gas, because see, that is a quantitative analysis. So ammonia gas should be collected in a proper way. Got the point? Ammonia gas, you should not, you know that ammonia, if you will recall that Bhopal incident, Bhopal, there is a gas incident. Anyone that doing, anyone out of you that know that about that Bhopal gas accident? Anyone heard about that one?
Yes, sir.
Yeah.
Methyl
So that,
isocyanate.
yes, that is the ammonia gas, due to the only
Yes,
the
sir.
ammonia gas, right? So ammonia gas, what I'm going to say, just try to understand. So ammonia gas has an actually irritation problem. So it will, if will do little bit more, so it can put up. It can be put up. So like that. So in that, why I'm going to say before starting this topic, this is the major influence. I give the some examples, so that's you can well customize with these examples. You know that thing. So in that actually in that West Bengal, in a school, higher secondary school, perhaps I don't know. That is called +3 level or +2 level. I don't know. But I have gone through that news. So that what happened, that some students were doing some kind of experiments, right? Okay, Mr. Kadar, do you want to say something?
Yes, sir. That is
Yeah,
methyl that is not ammonia. That is methyl isocyanate.
okay, maybe. So I just, okay, it may be mismatched with that one, no problem. Okay, but that is, thank you for the making me correct. Okay, that's fine. Isocyanate gas. Okay, methyl isocyanate gas. Good. Okay, so that's okay, no problem. So that is what I'm going to say. This is, but this fact is there, that is in West Bengal. That is the students who are doing some kind of experiment with ammonia gas. So that is that gas actually, the collection of ammonia gas should be in proper condition. Okay, might they are not proper guided by the, or they have that is skip that step and all the things. So 23 or 27 students or 17 18 students, they are feel sick, fell in sick, so they are admitted in the hospital. So that is what I'm going to say. Every thing having some issues. Yeah, okay, so everything as having some issues, so safety protocols should be maintained. I personally am telling you one thing, that is your, I told you about the chlorine gas asthma problem arises, and another thing I'm going to share. I went to conduct a practical examination as an observer, right? As an observer I went, so I was not dealing with that gas. Just a second please. Okay, so I was not dealing with that practical, but someone is there. I was there as a that is, as appointed as as an observer. I went to that university. I saw some students who are doing some experiment, and that I don't know what kind of experiment they're doing. Simply, I have to see that what is the observer duty. Is the exam is going properly? There is no, but it means cheating, all the things, whatever things. Lab is okay, that's all. And external is doing its job. But being I have a curiosity that to know that what kind of things they are doing. But suddenly I saw that one that girl, she was doing some kind of experiment, and that remaining, the residual part, she throw into the that is what in basin. Okay, but immediately that fumes come out from that basin. Okay, and then what is that, basin is connected to the plastic pipe, drainage pipe, right? So within few second of time, I saw that somewhere that in the bottom part of that pipe was melted. Then I guess that on it is sodium. Okay, It is purely sodium bulk that is you are doing some experiment, but residual, that remaining part of that sodium, she has to use in very few that is size of the sample. That's why we're discussing about the sampling, right? In the topic we have discussed about the sampling. Sampling is the most important one. How much amount or quantity of that a particular substance you have to take, you have to understand that one first. First you have to understand that one. So that's why you cannot take a much more size of that sample. So might be she has taken a big size of that sodium ball, and that water happens, she used somewhat, and the remaining she threw into the water. Then water happened basin and run the water. So what will happen? So immediately, as you know, that sodium is a group one element and highly reactive in nature. So immediately it react with the water, and just then exothermic reaction conducted. So that amount of energy was sufficient to catch the fire over that particular plastic. So it started to burn. Thanks to God, I just, because nearby areas where there are lots of that is what is that cylinders, gas cylinders, where the gas pipe connection was there, and also that is okay. I just immediately I was inside that particular lab. By that time I was there. I was observing the scene because I had to writing some report. I just remove that all the students from that lab and spray that is what is that fire extinguisher. Okay, then we control that system. So my point is, throughout my career within this 15 16 years of career, I faced twice. One along with that my students itself, that chlorine gas was asthma patient, and second is this was the examination time what I faced. Okay, that's why you will face, as you are the part of this analytical chemistry, you may face so many things. So it is my advice, being a teacher, I do have some that advice. Being the professor, I just want to say you one thing simple, I guide you. So whatever things you will do in the chemistry lab, it is not the any kind of lab, it is the lab where you can uh, uh, get lots of exothermic reaction, and also lots of that products which might be harmful for you. I don't know what kind of products is helpful for you and harmful for, I know that for me what kind of product is harmful. So I know when that kind of product any kind of things is that conducted inside the lab, so I just try to keep myself that is in safe mode, so that's how you can do the experiment in proper way. So that's why I'm telling you. So thing is that when this you are conducting any kind of experiment that in the lab, so you should be careful. Okay, you should be careful a little bit, so that's you can give your best to the concerned organization, to your future, and you have to learn so many things. So that's why nowadays precaution and safety manuals is coming. Okay, that's why this IGNO curriculum has set up such kind of precaution that is safety materials for all of you, that you can handle, you can read properly. So you should be thankful to the IGNO and the course build, that is professors, those are planning this one. You should be thankful because you will get this one. Because in when I was doing my PhD, so by that time, see that we are not having such kind of a precaution. Okay, we understood that thing. So but this safety material, safety manual is not provided by that course curriculum, right? So that's why you should be thankful to the IGNO that they have provided you the that is what one safety guide material for you. Okay, now come to the point, we'll go to the safety guide. Okay, so a laboratory is an integral component of a scientific pursuit. It can be place of a discovery of a learning. However, by the very nature of the laboratory work, it can be place a danger in if proper common sense precautions are not observed. What I told you, you know, you have done so many experiments. Okay, throughout your degree, you have done so many types of experiment, but that experiment what I have done, that is not actually the viable experiment for you, because the teacher will be there, he or she will guide you, do this, that, this, that, and that is not a, that is a huge. But now you are going to start, after this you are going to start, or some of you, out of you that you have in the professional field. So your this particular experiment will help, that particular learning point will help you and guide you how you will keep your lab safe, right? Nowadays you will not be more learner. You will the more expert, you will be in the more expertise field where it can do your where you can use your that what you have learned. That is the most important fact. Nobody will say you do this one. Your professor will tell go and do the experiment. You will go and you will do the experiment. Only you have to come with the report that sir, I have done the experiment, this happened, sir, tell me, is it correct or wrong? He will observe only that thing. I am going to say, or whoever your superior, they'll in the job profile, who is a superior, they'll only see your result. Nobody has no time because you are well customized in that field. I can trust you. Being a professor, I can trust you. I do have trust. Yes, this man can do or this lady can do this job perfectly. So I just left that lab. Only okay, no problem. If you have any issues, come and discuss with me. Because you are not kid right now. You are well customized in that chemistry field. So that's why lab experiment, because you will do the so many new things. Okay, that what I told you in the earlier time. Once the sample will destroy, nothing will be happen. You cannot do anything else. So that I think so. All of people have seen that movie or not? That Corona, that vaccine development. One movie is there and one documentary is there also. I have seen that documentary. How they have extract that. Why I'm going to say, because we all people, those are sitting here in the class and I am taking the class. Okay, so we are all that is have gone through that particular transition phase of COVID. Am I correct or not?
Yes, sir.
Okay, so that thing is that, so the people, the scientists, those are working over how they are that is decentralize that DNA from coronavirus and then experiment go on. So they are collecting the sample in a perfect way. So after that, what happened? Then if that particular DNA will be come out, then we can do the experiment. What is the we can read? So sample preparation was the most important area. So that's why in the lab precaution should be there. So that's why you are getting this particular thing, and that's why. So if proper common sense precautions are not observed, there may be the accident. What I told. A chemistry laboratory is full of potential hazards, sometimes even life-threatening. Okay, so as I told you, if will not deal the that hydrochloric acid concentrated 96 point purity. If that hydrochloric acid bottle is in front of you, 1 liter bottle, if will not deal it properly, it fell down from the that your working table to the bottom part, then everything will spoil. So that's why it is not, I am telling my experience. What is the precaution you have to tell in the lab? You have to take in the lab. You should tell to your friend circle. Don't do like this. So many times we have seen that, not like you, that all the students, those are in the right now in our class, but that generally we see so many students, those are in the graduation or a little bit in the young students, they don't know what is the behavior of that one, whether that will be a blast, whether that will be no reaction, they'll add something into the that particular test tube, or that is what is that your what is because they're trying to add that they're doing their own, then accident will be happen. Particularly, I do not give any space to any kind of my students in the lab to take this lab as a joke. Okay, that is my perception, because I see that what is written here over what I read, what I shared with you. See, a chemistry laboratory is full of a potential hazards, sometimes even life-threatening. So that's why everyone's life is precious. So that's why you should be careful. So that's why my thing is that it is therefore desirable that we follow good laboratory practices and work towards the safety of ourselves as well as that of the fellow workers. This is the statement what I told you. So you should be careful. Okay. Now come to the point. So this is the part what people think that is a story. It's a story, but it is the reality of the lab. Okay. So second thing, if you come down, I know honestly I told you that every experiment will be success with a good SOP. Okay. And also I told you, if the quality of the that your reactant is not good, so your experiment will be fail. That is also we have discussed. So that's why everything, if you are working under a good condition, if you are working with a good chemicals, so be careful, there will be good reaction also. So that might give you the great result. If you go through a proper SOP, if you do not follow the proper SOP, it may be something else. So for that, before starting this safety and all the things, before doing the practical, I just told you that what to do. So be careful. Okay. If you don't understand anything else, you just ask to your teacher. You just ask to your professor. Sir, I don't know what to do. So before that, that's why I told you what SOP should be there. Step-by-step procedure. What to do, what not to do, right? Okay, that you write. Don't go that in a monopoly matter. Don't follow that monopoly manner also. You have to understand the situation. Okay. Now we'll come to that. What is the objective of this one? Lists the potential hazards in the chemical laboratory. Okay. Actually, this okay. Next thing is state the need of the wearing the appropriate protective clothings in the laboratory. So as you know that chemistry lab without that is what apron is not, you cannot allow. And if you have any that is any problem with your eyes, so that means not power regarding that any means contamination problem with that particular any kind of gas or anything else. So protective eyeglass you have to wear, right? So also you have, if you have any use, I'm telling you, if you have any issues with that chemical with your hair, so that means you have to put the cap, right? Proper white cap, not any color cap, white cap you have to wear. So that means you should be gloves. When I started this topic, if you have that is you are using any kind of chemicals or any kind of acid, but particularly, so that you have to use your gloves, right? That should be. Next, recognize the necessity for personal code of behavior in the laboratory. So your what type of your personal behavior, you know that your workstation you have to understand, right? What the workstation I'm telling you, before doing any kind of experiment you have to choose your chemicals. So that chemicals put that area where you are working, that chemicals should be kept in a proper manner, right? And you should understand whether it is a hazardous chemical or not. The strong acid is there, weak acid is there, this is there, that is there, anything else, any kind of things. So you have to understand that is workstation you have to understand. Next is that state do and do nots in the chemical laboratory. What I said you, what kind of a behavior you will do, what kind of behavior will not do, you have to make a SOP that explain possible means of a chemical exposure to the human body. I told you very honestly, I told you this is mentioned here over. So what kind of a behavior, like I told you, suppose I have some asthma problem, so I should be careful about that some kind of a hazardous gas like chlorine gas, ammonia gas. Okay, sometimes excess amount of hydrogen gas may be create some damage, so be careful about that one if you're working in that zone. Okay. Next, okay, state possible hazards from the commonly used chemicals. See, suppose I told you about that commonly used hydrochloric acid. You know that what is the dangerous that factors associated with the all acids, strong acids. So group 1 elements like sodium, they are, if we put that only in that what is that in your bare hand, if you put sodium that hydroxide, it can burn itself in your hand, right? There will not injury maybe. So because contact with the that is moisture, it will react immediately. So that's why it is stored in the kerosene. Okay. So that identify the nature of the chemical and the required handling precautions from its level, right? This is another one. How to handle these particular things. Don't use your hand always. If you are that holding any kind of a test tube, okay, so hold with the test tube holders. So that is the scenario. Don't hold by your hands. Okay, I am doing some, I'm putting some water. Okay, now see that another strange thing, that distilled water and water, if you do not understand your what is fresh water and the distilled water, so there will be a problem. Actually, distilled water is not consumable. Okay, so it is not, it is used in case of what is your lab, but common fresh water you can drink. So that is the difference. You have to understand what is the nature of that particular chemical. Okay, and one more thing, see that your that is spirit, ethanol in purified form, it is consumable. It is used in the alcohol, right? But methanol is a type of alcohol. Ethanol is a type of alcohol. But there is 2 carbon CH3 CH2OH. Here is CH3OH. Methanol is a poison. If 20 ml of methanol, if anyone will consume, that optical nerve will be damaged, maybe blind. That person will be blind. If more than 20 ml, if you consume, that may be fatal. It is dependent upon the body, but it is poison. And one more thing, you have to understand, pure oxygen is a poison. Some of you know about these things, but ethanol you consume. Pure oxygen is a poison. It's not actually, we are not what type of oxygen we are inhaling, that is not the pure oxygen, it's a mixed air. So our body has several, it's a human body is a that is human body is the actually human body is the topmost. There is no other lab in the world like human body or animal, any kind of animal body. There is no that is lab. A particular structure in human body having lots of processes going on throughout day and night, unlimited. Okay, now we'll come to the point. Identify nature of a chemical and required handling precautions for its level. Okay, explain the importance of a compatibility of the chemicals while storing them in the laboratory. See, I told you, if there is sodium and it will keep in the that open that is container, then what will happen? It will come contact with the that is moisture, then reaction will be there, then is a huge blast. That's why sodium will keep inside the what is kerosene. It's a non-reactive inside the kerosene. So many things. When I am giving, if you are using acid, okay, any kind of a strong acids. Okay, one more thing. That is, you have seen that some that is okay, hydrogen peroxide. If you take the example of hydrogen peroxide, why I am telling you it is because in your daily practice level, so many that is compounds like this will come in your means experiment. Hydrogen peroxide. If hydrogen peroxide storage, you cannot put the hydrogen peroxide in a transparent bottle. It's maybe the glass bottle, no problem. In glass bottle you can keep, but in the transparent where the light is passing, you cannot keep that. That's why hydrogen peroxide stored in a that is what in the dark bottle. Dark bottle where light will not pass. Then what if light will pass? It will break down. Then it will not neither it will, again it will convert into water and oxygen. Highly reactive. So storage of the you have today in your lab you make some hydrogen peroxide and stored in a very good, nice, beautiful bottle is keeping in the your lab. You stored in that 250 ml of hydrogen peroxide, and you told that yes, I today my experiment is success because tomorrow I'll second experiment I'll use this hydrogen peroxide in tomorrow experiments. Then my result will be I'll get the best results. And I'll be the champion. But you made a mistake. You store that hydrogen peroxide in a transparent bottle. So tomorrow morning you will come and you'll open your lab and you will do what is you put the hydrogen peroxide, 10 ml of hydrogen peroxide into your that next level of experiment. Then what will happen? Result will be 0. So that's why Storing of chemicals, you have to understand which chemical you have to store. That's most important. Okay, now follow appropriate safety precautions while dealing with the chemicals, glasswares, apparatus, and electrical equipments. I told you this several times. Several times I told you. So these are the electrical equipments, means electrical current will pass. If faulty equipments, there will be shock. Okay, that is the issue. Then take steps to provide help to yourself and the fellow workers in the event of an accident. Okay, this is the another things. So it is the most important objective of this particular chapter. So that's why I kept this unit for you in the today's last part of my class, this particular unit. So that's why I kept for this one, because I can explain what is the importance. As you know that I don't know that out of you how many people are handling this that is perfectly this lab equipments. I don't know, I don't have idea. So maybe you have handled that your lab equipments perfectly. That does not matter. So matter is, being a professor of the chemistry, I have to explain all the things, because after this that class, you should not think that what I told you, that when I was there in PhD, so by that time also we don't have this precaution, what is the safety manuals. Right now it is our responsibility. Safety manuals we have to tell you. Okay, time to time modification happened. We are not giving any kind of someone should be guilty for this one. We are not telling that one, but that mechanism was not there. But right now, that time to time when I reached, it is my that a duty. I have to explain all the things. I may not leave these things, okay, into the dustbin. That's why I told you this. So many things will come, but it should not come to your mind that sir has not taught us this fact. See, he has not told something like this. Okay, I shared some experience. We discussed some things, and that methyl isocyanide. Am I right? Methyl isocyanide.
Yes, sir. Yes, sir.
Okay, sorry for that one. It was, I think it is wrong. Okay, so it was methyl isocyanide was the Bhopal gas incident. You all are right now, the pupils are suffering. Lots of things are there. Okay. Also, you can say that atomic bomb was there on Hiroshima and Nagasaki in Japan. Today, the people also suffering in that. That is a chemical reaction. That is also a chemical reaction. It's not a bomb. Right now, today's any kind of bomb having the chemical reactions. You know that right now that what is Russia and what country to that? Russia and Ukraine. Okay, they are fighting with each other. We don't know. Okay, so my thing is that what are that bombs and missiles were there, so that reaction will be there. That is a chemical reaction. All so many types of chemicals used in that particular bomb and materials. Okay, that two country will not suffer in that. Whole world will suffer. That's why global climate changes is there nowadays. Okay, now we are not feeling cold. We are not feeling that is there is no rain anytime. Maybe that a cyclone happened, rain, everything is spoiled. Winter, okay, today is too much cold, tomorrow is too much hot. So our body cannot alter the regulate as per their climatic condition, because we people are responsible. As you know that, so you're using by that nowadays that your what is ozone layer deflating. That's why the glaciers and all the things nowadays. 2 days back, I was watching that movie. Television. So news was there. So some area that glaciers were actually, I have not found out all the things, but some glaciers were melted out. Something is the scientists, whole world scientists were suffering. From India, 3 scientists were there. 2 from that, one from Tamil Nadu, second from Maharashtra, third from suppose from that Cochin or something. 3 scientists were there. They are working together. What is the thing scenario is going on in between this? That's why this is happening. They are doing their experiment. Okay, so it is my prospect to inform you all the things. So that's why you should be alert about that. Okay. Now, come to the point: maintenance of safety in a chemical laboratory. Maintenance of safety in a chemical laboratory. So first step, safety aspect in the design of a chemical laboratory. So this is the actually that now see, okay, it is essential for you because for your professional life. If being a chemical analyst, you should know that what is the steps should be taken when the chemical laboratory will be established. But now you are being a student, you are working in that particular established chemical laboratory. Only you are dealing with the chemicals and its instruments. But in the professional life, you have to understand how the chemical laboratory should be established, where the chemical reactions will be conducted, right? So then this is the point. So there should be adequate provision of for lighting and ventilation as and reasonable temperature. The chemical laboratory should be comfortable place for work. Okay. By actually the thing is that if I'll give you 2 3 facts. So the temperature, the thing is that I have seen one chemistry lab of a college, right? So I went for the inspection. So I saw they put a AC in that air conditioner, split AC in that chemical lab. Okay, it is not running, but it was that is they have means installed that. Anyone can say out of you. So is it feasible? Is it okay with the chemical lab, the air conditioner? Can anyone say that chemistry lab should have one air conditioner? Anyone, yes or no?
Sir, it is okay if the fume heat or draft is there for the um, acid or any other vapor generating purpose. Then it should be okay. Otherwise, it should be well
I,
ventilated.
it depends. I am asking about the split AC.
Split AC, okay.
Mr. Kadar, are you telling what actually?
Yes, it is okay.
Yes, sir.
Because in Saudi Arabia, so many laboratories, it is having the all split AC. Some central AC also there.
Okay.
I am working with the bitumen.
Okay, right.
laboratory.
That's why I'm asking you that. So I saw that. That is my experience.
But
So
heating food should be there. Heating food should be there.
exactly.
Yes.
So it
Yet
should
you
be.
spoil that one.
Exactly. That is the point. So depend also. You are absolute right. So thing is that when we are using this one, if you are see to maintain the temperature, reasonable temperature. What is Mr. Kader told? That is that temperature is high there in Saudi Arabia. So actually, I have to give a room temperature condition. So sometimes that to make it proper balance. But if I say in India, like your this is the what is that state like okay south like Andhra Pradesh, Tamil Nadu, then might be the temperature. If you come down towards the Haryana or that is Delhi, so always the temperature is not high. Sometimes in the summer season, so we should not use that one. So that's why precaution steps should be there. Okay. Next, there should be effective measure to prevent the inhalation of fumes that are likely to arise during the work. So that means proper ventilation should be there. When you are doing any kind of experiment, your windows should be properly, or else if it is AC, if it means controlling the temperature, you have to exhaust system should be there. Then fumes, whatever the arises, that will go away. So you have to the geographical location. So on the basis of that, you have to make it. The dangerous part of machinery like vacuum pump must be properly fenced so as to avoid mishaps. Okay. So that is the thing. Okay. Now the laboratory must have the first aid box with essential constituents. Okay. That is the another thing. Adequate fire prevention measures must be undertaken. So every fire extinguisher should be there. Okay. So fire extinguisher should be there and adequate things. Which these necessary equipments and facilities for extinguishing fire should be available and handy. Okay. If we come to the point, This is the photograph of modern chemical chemistry laboratory. So if you see this one, I just zoom this one. I'm zooming this one. So this is a type of modern chemistry laboratory for the studying, not for the working purpose, for the studying, the lab work. So what I told you, so that there is in picture you will see two person will work in the past. What is in front of right now? What picture you have seen? That are two working stage. Okay, so all the equipments will be there. On the basis of that, you can do the okay. You have to do the work. Now the thing is that. Okay, next, if you come down, safety aspects of a functional chemical laboratory. What is the safety aspect? Once the laboratory becomes functional, it needs to be suitably maintained in safe working conditions. The following measures are essential for the effective running of the chemical laboratory. What are that? The condition of the building, furniture, fire safety units, electrical connections and appliances, water pipes, etc. may be checked at least once a year. Any repair requirement must be attended to. Not at least one. So I'll say that every 6 months or every 3 months it should be. And the big laboratory, so the technical parts are there. So they're usually they follow the rules, precaution rules and safety checking measurement every 2 days or 3 days. But throughout the year, you will see that that AC system is there, so it should be checked in properly. Okay. Now the thing is that at the time of a purchase of a gas cylinder, chlorine gas, oxygen gas, etc., the safety instruction sheets must be obtained from the dealer and preserved for the use. Okay, that is the most important thing. Okay, sometimes that you will be the part of this one, you should be take the responsibility of this one. You should be the accountability of this one. The lab staff should be provided with the protective clothing and must be immunized against tetanus. In addition, the laboratory staff must have the appropriate training in the following aspects. What is that? Handling equipment and chemicals, using gas cylinders and firefighting equipments, storage of chemicals, moving loads, waste disposal, administrating of first aids. Okay, that is another thing is waste disposal. Waste disposal is the most important things. So you should not pour all the things into the basin. You should not. What usually you do, what are the remaining part you throw into the that is basin and around the water. What I told you, just when I started this topic, I told you, I saw one student who was putting that residual part of that, it means remaining part of that, what is sodium into the basin. That's when they see around the water, then fire caught. It should not be. We have to understand that whether I'll throw into the basin, whether I'll throw into the plastic, whether I'll throw into the other side, when say in the general soil and all the things, when proper disposal things I am using. So you have to understand about that. Next, the lab must have a list of important phone numbers and addresses for use during the emergency. Okay, the said list should be prominently exhibited in the laboratory and should include the contact number of the following. We don't know that when the accident happens, this should be. So nearby doctor, hospitals and ambulance service, police, fire safety authority, electricity supply agency, gas and water supply agency, and firefighting equipments dealers. So these are the precautionary steps inside the lab we should follow. Then code of practice in a laboratory. What type of code of practice? See that what is my experience is telling that so many questions may come in your exam on the basis of the safety in laboratory, because you have to be careful about this one. Don't neglect this particular unit. This is the area. Is the actually this the what you will do, how you will do, everything is here. So now the thing is that do and do nots. Always wear the required protective clothing like laboratory coat, goggles, gloves, etc. I told you this. Particularly, I told you because several we are using these three things particularly. So that you have to use also. So that apron should be there. Means white clothes. Full, it's fat. Not only the coat, so you have to, if you pant and that coat, that is good, okay, and also cap, white cap, everything should be in white, and also goggles, that white goggles, that non power, but it should be cover your eyes, and gloves for dealing with the acids. Okay, then wear shoes. Okay, now the shoes is important, and also, so what will happen, see, wear shoes that adequately cover the whole foot. Low heel shoes with non-slip sole are preferable. Do not wear sandals, open-toed shoes, open-back shoes, or high heel shoes in the laboratory. That means when is your practical, you should be careful. When you are going to lab for any kind of work, you should be careful. Right? You should be careful. Neither you know that you can't run. Slippery means water will be there, the floor slippery is there, or something else is there, any kind of liquid is there. So if that is sole is something like a slipper, and that your sandal and all this, so slippery surface might be the problem. Okay, the tie long hairs and secure loose clothing, especially the loose long sleeves, neckties, and scarves, etc. So this is the particularly these things you have to be careful. Okay. Now the thing is that keep the hands away from the face, eyes, mouth, and body while using chemicals. What I told you, this is written over there. You should be careful when you are using that particular chemicals. We don't know when, what thing will be happen. Okay, just a second, please. Okay, now the things that find out the position of the main valves or switch for controlling supplies of water, gas, and electricity in the laboratory. Okay, that is your job. It is not the job of that everyone. So sometimes what happened, where we are doing our means workstation, nearby that there will be the gas supply, that knob will be there. Okay, open and close. So what we will do, sometimes if anything will happen, so it is our responsibility to switch up that knob or open that knob, right? So we do not wait for someone else who will come and do that. Okay, so be careful about that one also, regarding the water also, and other things. Inspect all equipments for damage prior to use. Don't use damaged equipment. If there is, we have discussed about this, if there is faulty, that is any kind of faulty equipments, so don't use that one. It will spoil your experiment, and it may be so you have to put down 2 drops. So if faulty equipments, it may be 10 drops, so might be the more reactive in nature. Okay, next, inform other lab staff and teachers regarding any breakage, faulty equipment, and any other defects immediately. So sometimes what happens, students do not share the things with the teacher if it is broken down, right? So it is better, because sometimes what happens, some organization put some fines. In case of college, I have seen, I heard some colleges put some fines because you have destroyed that lab equipments. Okay, so to actually the students should not do these things. But what will happen if it happened? So do not hide these things. You should share your teacher. Okay, so then they can take the proper steps. Wipe up any spilled chemicals immediately, especially corrosive acid and alkali and mercury. So you have to, if acids like that, sometimes workstation contains concentrated acids, if it is there on that your workstation, so wipe out. It means you have to Actually, you have to remove that one. Neither again your hand will be there, or that surface, I don't know that what kind of a corrosion maybe arises. So be careful about that one. You should wipe out. Next thing is that keep the apparatus which is no longer required in the cupboard. If you make your workstation clumsy, if it is not useful, so just keep away from you. What is essential part, you just keep with you in nearby that workstation. So other things you should have to remove. Okay, if I don't have work with the barium sulfate, I have already finished with the barium sulfate, so why should I keep that bottle, that box with me in my workstation? I have to keep away. Okay, next, use a fume cupboard for transferring highly toxic substance or for carrying out experiments which may produce harmful gases. So this is the things, what I told you, that if any kind of that harmful gases you are using, you are doing any kind of experiment, so you have to keep that is particular fume cupboard, so then you can remove it. Then operation considered hazardous should be carried out only in the place designated for the purpose of the ensure that the can get assistance if required. So if you think that the experiment is hazardous, means any dangerous condition is there, if you think your SOP, if you mention that there is, in the SOP there is any hazardous things are there, so you have to be careful. You have to do that experiment in proper proper conditions. Okay. Next, always label container correctly with the full name and concentration of the contents. If you are keeping any kind of acids, any kind of chemicals, any out means B container to small container, so it should be labeled with the proper name. Suppose you are using hydrochloric acid concentrated, you have to mention with a proper, means it can visible properly. So concentrated HCl, hydrochloric acid, HCl, dilute HCl, you have to properly mention. Don't make it small size, it will make bigger size, proper visible. Then use a hot water bath to heat flammable liquids. Never heat directly with the flame. See, if it is means liquid having that low boiling point, okay, so that means it can catch the that is the thing. So, or high boiling point, you have to check it out. So then under that precaution you have to do the experiment. Always use safety balls when pipetting. So this is the another things repeatedly I told you about the pipetting. So you have to be careful about this one. Always use a spatula to remove a solid reagent from the container. So sometimes we use our hand. Pepper, I have seen. Don't use that. Spatula you have to use to that bring that particular solid that reagent, any kind of things. Okay. Then never use metal spatula when working with peroxide. See, if you do the work with the peroxide, with the metal spatula, then oxidation reactions will be there, then highly exothermic and maybe dangerous condition. Always wash your hands before leaving the laboratory. That is the important thing. Okay, it is for your precaution. Clean your laboratory workspace at the end of the laboratory session. Every day it should be neat and clean, because you don't know what kind of chemicals on the work table and it is spreaded away. So tomorrow, next morning when you will come and you'll again do the experiment, that you don't know what kind of things will be happen. If will again that any kind of a mixing will be there, any kind of reactions may be happen. Okay. Next, make sure you know the emergency procedure and emergency exit route of your laboratory. Okay, that is important. Ensure that the doorways and emergency exits are not obstructed with the trolley, furniture, etc. Next, ensure that means that your road should be neat and clean. Ensure that, okay, so in case of an emergency or accident, follow the established emergency plan as explained by the teacher and evacuate the building via the nearest exit. Okay, so you have to follow the if anything happens. See, I am not telling that It will not happen. If it will happen, what to do? We have to take precaution. We have to think about that particular experiment before doing. And in one lab, you are not doing one kind of experiment. So many things, so many person will do so many types of reactions. So many people will do use so many type of a reagent. So may happen. That is not the issue. May happen, but we have to make ensure before doing any kind of experiment that 100% safety procedure we have maintained. Okay. Later on, if anything will happen, then we'll see that. Okay, but after that, follow the guidance of that particular teacher or whoever present there. What do you have to do not? Just a second, let me to drink water. Okay, just a second, please. Okay. So do not sniff material which may be toxic and never test chemicals. Sometimes we put the chemical into our mouth. But I told you that a finger touch knowingly or unknowingly. So if your finger touch to the that chemical and you put our knowingly or unknowingly your tongue, might be anything else. So you should be careful. Never work alone in the laboratory. But sometimes that okay, this is the scenario. Never work alone in the laboratory. That is the but what to do? We are and sometimes we work alone to complete my project or something else. Usually we do alone, but it is precautionary step. You should be. Never perform any unauthorized experiment to leave any experiment unattended. Okay, this is important. Without any, don't do any kind of unauthorized experiments. Like what I told you, some students add some chemicals to see what happened. But thing is that might create that damage. Okay, don't leave lit Bunsen burners unattended. This is another thing. Don't remove any equipment or chemical from the laboratory. Don't actually that disposal of things should be in proper way. Don't allow organic solvents to accumulate in the laboratory. If it may cause a fire accident, especially while flammable solvents are stored. That is another thing. Organic solvents. Minute particles in a smoke may interfere with the spoil purification, chemical processes, and electronic parts. So that is small particles should be if it there, so it will be damage. You don't know which react with what. Hot zone of the lighted cigarettes may help in the formation of poisonous substances in presence of smoke chemicals. Don't look into the mouth of the test tube or flash while you are hitting it. Okay, this is the things. Every time when you are holding the test tube or any beaker or anything else, so don't put your, so always try to show that in a tilting condition, it's just little bit angle and show into the fire, and don't put your eyes or mouth into that the face of that particular test tube. Don't keep, so just keep away yourself from that particular experiment. You can see, you can observe, you can smell You can smell that whether chlorine gas is formed, ammonia gas is formed, or that is color changed or not. That you can observe by your eyes, and you can smell it through your nose. So, but don't put your nose or eyes or face into that particular things. Before using flammable solvent, check that Bunsen burner are put out and that there are no naked flames. So actually this will catches fire. Do not engage in practical jokes or okay, no problem. The conduct in the lab. So that is what is your bad practice in this case. It is not acceptable in the lab. Okay, avoid touching hot objects. Remember, hot glass looks just like a cold glassware. Okay, so you don't know if you test tube is actually hot test tube looks like the normal test tube. If you hold that one, so don't try to touch that one. So that's why I told you, you just always hold the test tube by using your what is test tube holders. That these are the things, so many things are there, you have to go through this one. Okay, another thing is a long hair and a ties. So thing is that this long hair and a ties, okay, it is not allowed. You have to properly knot your long hair. You should not wear your ties or any that is means what is very that is open clothes, right? So it is not allowed. Simple tight clothes is essential. That's why we are using our what is that is lab coats. Okay, so long hair, ties, and loose jewelry could not be a problem during the laboratory work due to possibilities of entanglement in moving mechanical equipments or trailing over the. See, that is, I don't see that this thing is. Try to avoid this. Okay, so try to avoid this. So I am not telling that this kind of things will do the any kind of harm, but thing is that it might be. So better to keep these things away. This is the practical things. Okay. So that is the point. Okay, next come to the point. Personal protective device, lab coats. It is compulsory. Lab coats is essential. That white coats is essential. Okay, that is full sleeve. Then safety goggles. See that safety goggles is that it is used. Then the gloves. When you are using any kind of things, you should wear the gloves. Then come to the point. Chemical hazards in the laboratory. What kind of a chemical hazards will be there? See, the first most exposure to the chemical. Dermal exposure means skin, direct contact from the spills and the improper handling. If that is you are not handling properly, then skin may be damaged. Second, inhalation of the vapor, fumes and dust. Okay, that is inhalation. Ingestion, the oral route. If you put the chemical direct into the mouth, then it will be harmful. Fire caused by flammable liquids. Okay, like that I told you, sodium, if you put the sodium and water into together, that will be more that is exothermic nature and it will cut fire. Explosion caused due to the improper handling of chemicals. Okay, that might be the explosion. So that's what will happen, that when that heat cause, if you hold the test tube and doing any kind of a exothermic reaction, and the test tube will be that is heat will be evolved. So then what will happen? I can hold the test tube by hand, I will throw. So then that area will create the damage. I don't know that where it will fall down, what to happen, with which the chemical it will comes in contact, what type of a reaction will be there, we don't know. So that's why be careful about this one. Then dermal exposure. So what is dermal? With our skin is effective of barriers of many chemicals, however, whatever it may be, but it is a common route of the chemical exposure. So that's why you have to check it out. Inhalation is that most poisonous gases are there. Ingestion, if you orally, if you put your that some chemicals into your mouth, then it will be happen some problems. Effect of chemicals on body. Okay. Then what will happen? Chemicals on the body. See, you have to understand what type of chemicals, what kind of a behavior on your body. You have to understand that one. Okay, so let's see that one. If we'll check it out, so acid, What an acid can do, what an acid can do, that is the thing. This causes severe bones and a tissue damage. It will fall on your body. So what will happen? It is severe pain along with the damage of the your epithelial tissue, or that is normal skin. Some of the commonly used acids are acetic acid. Okay, no problem, acetic acid, but okay, chromic acid is there. It's dangerous. Hydrochloric acid, nitric acid, sulfuric acid, carbolic acid, phenolic acid. So this type of acids is used. Usually that acetic acid is not much more that that vinegar is there. It's okay. Simple precipitated that simplified process is there. But strength, it may not damage. But sometimes what happens that if it is that my body is not permitting this carboxylic acid or acetic acid, I am not, means biological metabolism is not allowed to take this vinegar, then what will happen? So might be cause some problems. Okay. But this your chromic acid, hydrochloric acid, nitric acid, sulfuric acid, as a phenolic acid, so these are the actually the acid behavior is on the skin will be that it will be damaged. So be careful. Alcohol, these irritate mucous membrane. So methanol can cause, I told you about the methanol can cause blindness or ingestion or on prolonged inhalation. Okay, so I told you initially about the methanol. So ethanol is a purified ethanol. We can that is pupils are taking that alcohol, it is used, and in some also medicine it is used. Spirit also we can use, that is purified ethanol. But methanol is poisonous. Okay, methanol is vital. So that's why what will happen? So I actually once I faced one thing. So I just washed my hand with the ethanol. Okay, but I asked to a student, so give me that ethanol bottle. Okay, ethanol bottle. I asked her because I want to wash that my hand with that ethanol. Okay, so that I asked a student to give me that ethanol. He gave me a bottle. Okay, but ethanol and methanol both are same. It is my personal actually. Ethanol bottle and that methanol bottle where packing is equal, but it's mentioned, name is mentioned is big. So when that that student gave to me, so I thought he has given the ethanol. Okay, then I put that ethanol on my hand. Okay, I thought that ethanol, but it was methanol. So I put that one, and then when I put on my hand, the smell gives me means it's it's a ridiculous smell. That's a very very nasty smell. Then what I gave, then I saw the bottle, that is methanol. Okay, no problem. For around that 2 to 3 days, I washed several times, but I am unable to eat. Honestly, I unable to eat, but through my hand. You eat usually by using the spoon, but that is same thing when the smell comes out. So it is hilarious. Okay, so be careful about that. Methanol is poisonous. Then if you come to the aldehyde and ketone, these cause irritation of the tissue and produce narcotic effect on inhalation. Okay, absorption and ingestion. So narcotic means drugs category. So if you that is aldehyde ketone as a carbonyl group is there, so it has that behavior is narcotic behavior, means drug category. So it means will not feel good. So that is the behavior of it. Direct ingestion, if intake of that. Okay, so that's why ketone actually that aldehyde ketone used in the what deo, perfume, and all the things. So that's okay, but thing is that you should be careful about that direct ingestion. Next is alkalis: sodium, potassium, ammonium hydroxide. Sodium hydroxide, potassium hydroxide, ammonium hydroxide can cause severe tissue burns and that is bronchitic problems. Okay, so that these things will cause severe means I know that these are hydroxides, alkalines. So that's why tissue irritation will be there, itching will be there, burn will be there. So be careful when you are dealing with any kind of a chemical. That's why this is the important area. Okay, carbon monoxide. Prolonged exposure of carbon monoxide is toxic and may prove to be bad. As you know that carbon monoxide is a pollutant, right? So carbon having that is triple bonds. One is dirty bond, one is sigma bond, one is pi bond, and that dirty bond, that's coordinate bond, is also type of a covalent bond, right? So that is thing is that so as it is more stable in nature, so that's why the carbon monoxide is a hazardous, is a poison, it's a gas, poisoning gas is there. So be careful about that and don't much more exposure to the carbon monoxide in the lab. Then compounds of a sulfur, phosphorus, and a nitrogen. So these substances corrode the skins and destroy the respiratory tracts. Okay, that is another thing. Cyanides. These are highly toxic if absorbed, inhaled, or ingested. So that means you know that cyanide is a highly poisonous thing. So it will not give a single space for the any kind of treatment. Okay. Then if you come to ester, exposure to ester causes tissue poisoning and irritations. Then if you come to the ether, these produce a powerful necrotic effects on inhalation. Okay, ether. So halogen, these are corrosive and highly irritation of tissue. I told you about the chlorine gas. Okay. So hydrocarbon, inhalation of hydrocarbon causes irritation and tissue destruction, prolonged exposure. So that means majorly if we see that a respiratory tract problem will be there. So those having the any kind of a respiratory disease like the asthma and all the things, okay, bronchitis, asthma, this is the nowadays is a common disease. Okay, so asthma, I don't think so it is curable or not. I don't know, the medical science persons will tell, but I have seen lots of people that are suffering from the asthma, they're continually take the medicines, okay, continuously. So whatever things, so that's why because due to the pollution and all the things. Okay, that those are having the asthma, so it is my personal suggestion to all of you, so be careful in the lab. And you should inform to prior, you should inform to your teacher that you have asthma problem. Means that any that is respiratory disease if you have cough and cold. So sometimes what happened that if you have a high BP, okay, and you will be there inside the lab for longer period of in the gas, so BP will be triggered. Definitely. So many things are there. If you have low BP also, that you should be medically fit. Sometimes means I'm not telling about that sir, all the time, but you should be medically fit. You should be fit for the lab process, because sometimes so many gases are there which triggered what thing I don't know. So things that you should be careful about that. Okay. Then mercury is quite toxic in nature. People on the table, that is I do workstation, you are doing your work and the mercury is there, you know that mercury in the liquid form is so if you there on the table and you toss, I mean accidentally you toss that one and you put in your mouth, so it's dangerous. Okay, because it collapses the heart immediately. So be careful about that one. So extensive handling of mercury or inhalation of its vapor may cause tissue poisoning. The toxic effects of exposure to the mercury are compounded with prolonged exposure. Okay, acute and chronic effect. This is another thing. So thing is that you see acute and chronic effect. So you have to differentiate. Maybe the question will come: what are the acute and chronic effects? So you have to read these things perfectly. So then the effect of the accident due to the chemical are severe and immediate on the human body. These effects are called the acute effect. Instantly what will happen and can be traced without difficulty. Frequently, poor lab practice or an unsafe system of work will lead to the gradual poisoning. At first, effect may be go unnoticed, or effects may be attributed to the wrong cause. Maybe okay. So actually, that what will happen in this case, that acute is that immediately accident will be happen. But what will happen? See, usually every time some gases will release from some source. We don't know. Suppose that some exposure will be there, some that a chemical content is properly is not sealed. Then what will happen? So gases will come to the moisture and gases it is a slowly it is going on, right? So throughout the lab, that gas is spread every time. But as you know that, So lab having the several type of gases and chemicals, so lab smell is something different, right? We cannot notice that thing. But what will happen, suppose for me that particular gas is not suitable, okay, time to time I have inhaled that gas, so what will happen, that again in my body will be react with that gas accordingly, so that case will be chronic. Then that should be, chemical laboratories should be a perfect one. If I visit to the that my personal suggestion, if you visit the NISER or ISER or IIT lab, chemistry lab, you will see that how safety is that. But still might have some issues. Okay, still might, because SOP we are not following. Lab is fine, but standard operation protocol, what to actually one student should follow or one to professor should follow, if that is not followed perfectly, then accident will happen surely. Okay, but sometimes this type of leakage of a gas, or if you see that container, if sealing of that container is not perfectly done, that's why some experienced person, that those who are dealing with the lab should be attached. Okay, so the chronic effect, the acute effect, drunkenness and vomiting. Okay, means it's feel like that immediately. Chronic effect, addiction, liver damage, etc. Got the point? Okay, the fume cupboard, this is another thing. So to it's mercury should be should be in the mercury dust or harmful gases should be used by this fume cupboard. See, that is the fume cupboard here, so it should be there, fume cupboard. Fume cupboard, note the provision for the gas, water and electrical supply. Okay, this is the thing, fume cupboard is that, so it should be there. Then we'll come down to the classification of hazardous material. What kind of hazardous material is used in the that lab? Explosive. Okay, so as you know that nitro compound, any kind of nitro compound, this is actually that used in to make different kinds of explosive that items, right? So nitro compound, this is a highly explosive in nature. I'm telling you about that. Nitro compound, if you see any kind of a nitro compound, any that a container having the nitro NO2 group is there, so be careful about that. Be careful. It is highly explosive in nature, nitro compound. So usually that it should be carefully handled. The explosive are defined the chemical substances and preparation which may explode under the, see, there is a mark. If in the chemical there will be a mark, you have to understand the mark. Like that, if people having that driving license and you have gone to the that RTO to get that driving license, so you have to understand that mark. This, what is the symbol of this one? What symbol is indicating this one? What is this? Track is given, like that. Okay, so like that in chemistry lab, so many that the container of that particular chemical having that some kind of pictures, right? You will see that this is one left side, there is a picture explosive. You have to understand that what is the nature of this. So that's why before using that particular container but chemical, so you have to check it out, that container. Okay, and you have to think, you will get some information from that container itself, right? If this mark is there, that the hazardous means it's a what is that, explosive one. Then actually that sometimes what happened, we have used some compounds in a hurry way, we have forgot to that understand these things. So that and experience is the most important factor. So that then we will come to the point, the that if compound the include the commercial explosive preparation and substances used as blasting agents, ammunitions and fireworks, etc. Some examples are gunpowder, chlorate mixture, nitrate mixture, nitro compounds, fulminates and ammunitions, fireworks, detonators, etc. So it is used, actually this compound is used that particular thing. So that's why mostly nitro compound, all these compounds you have to, this is the derivatives of the major compounds. So Nitro means nitro is there if there is any kind of what is that nitrate ammonium. See, ammonium nitrate nowadays banned in the lab, but for you people will get, right? But the small lab, ammonium nitrate is banned, right? So thing is that time to time you will understand what is the hazardous nature of this particular things. Okay, now the gases, a substance which has a critical temperature below 50 Celsius, 50 degrees Celsius. I told you right now before time. So caught fire. So if the critical temperature below 50 degree, so temperature, critical temperature below 50 degrees Celsius, then what is a normal room temperature nowadays in our if we work? So that means below 50 degree will caught fire. It will caught fire. So that's why that is a mark. It will immediately it will caught fire. So you have to understand that is what is the that's why container, as I told you earlier. So that container you have to see that before using the chemical you have to read the tag, you have to see the picture what is there. So this kind of picture will be there, that will be flammable, highly flammable. Okay, then flammable gases which ignite on contact with an ignition source such as the acetylene and hydrogen. So if these kind of things are, acetylene is there, hydrogen gas, and there if we, your Bunsen burner is working and you have hydrogen gas, acetylene gas is there, so might be explosion. Okay, then non-flammable gases you have to understand that one. Is it below 100 degrees Celsius? Poisonous gases is there, gases liable to cause death or serious injury to human health if inhaled. Examples are fluorine, chlorine, and hydrogen cyanide. It is in the, that is in the amount of, I told you about the chlorine gas right now a few minutes back. So chlorine gas is hazardous, right? So means if we inhale much more things, so but little bit we do the, so we have to inhale, neither we cannot. Okay, we collect the gas, then we will go for the test. So usually what will happen, the what gas is released, we have to, because we are testing with the test tube, it's open surface area, right? It will come out, so little bit will come. So that's why sample of that particular chemical should be small one. If you'll take the small sample, then gas, that gas what will that is formed, that will be little bit. So then it will not affect your body. But continuously if you do same experiment with the proper precautions, so it will damage your that is what respiratory system. Then flammable liquids. See that flammable liquids like that, it is highly means aggregation of that one, it will create damage. Okay, then flammable solids. See that the picture you have to see flammable solids, right? These are the flammable solids, highly flammable in nature. So oxidizing substances. Oxidizing substances, I have told you that peroxide, if we keep peroxide in the, that is what in a transparent bottle, then what will happen? Sunlight will be passed, then decomposition reactions will be there, that will turn into the water as well as oxygen gas. It will means it will be so oxidized. So thing is that, right, oxidized means chemical will be damaged again. Okay, right? Then organic peroxides, dangerous when wet. Okay, now the thing, this is the important point, dangerous when wet. So solid substance that emits a flammable gas when wet or react violently with water and grouped in this class. For example, sodium. I told you my experience few minutes back. I shared with you that my experience how the fire caught. So due to this sodium. So these are the group 1, group 2 elements. Be careful about them. Group 1, group 2, that is your lithium, sodium, potassium, rubidium, cesium, francium. So you have to understand about these things, right? So these group 1, group 2 members, you have to understand their behavior. So be careful when you handle these things. Okay, don't think about that. Then they are wet. When they are wet, usually when comes in contact with water, moisture, not only water, moisture. If they will come in contact with moisture, they will caught fire. Okay, some exothermic reaction will be there. So poisonous and infectious substances, toxic substances. See that symbol of toxic. Biohazards is there, right? Biohazard substance, as the name suggested, there is substance, radioactive elements, right? Biohazards means these are the radioactive elements. They have the lifespan is very 30 seconds to 1 minute. Mostly 30 seconds to 30 minutes, 30 seconds to 30 minutes, they will be then degrade. Right. So biohazards, they'll immediate reaction. So that's why biohazards are there. So as the name suggests, these are the substances of the biological origin. These are further subdivided as follows: infectious substances affecting human body and all the things. So that is there. And things is that waste of residual of materials. So these are the biohazards problems. Radioactive elements, right? These are the usually biohazard cause the radioactive. So radioactive elements cause the biohazards usually radioactive. These are the radioactive nuclear reactive things are there. So be careful when you're dealing with the radioactive elements and biohazards, right? Then corrosive substances, it will damage, it will toss in the any kind of floor and all the things. So corrosive nature in that. So corrosive miscellaneous dangerous substances, like see that here is the hazard identification. Okay, see that identification is by color also. This is one area that which you can also memorize for your when you are do some kind of work. So color that explosive, sorry, this is actually that mistake is there. Nature will be this side, that color will be that side. So here is some that is, so nature is explosive, color will be orange. Nature is flammable, color will be red. Nature will be water reactive, color will be blue. Nature is the oxidizer, color will be yellow. Nature is a toxic infectious, that color will be white. That nature will be radioactive, color will be white, yellow, or white. Okay, white or yellow. Okay, and white or yellow. So nature is the corrosive, that color will be black and white, right? So then carcinogen. Oh, why? This is an important area actually. Carcinogenicity. Anyone have an idea about the carcinogen?
Yes, sir.
Okay.
Cancer.
Cancer causing, that cancer cell developing that particular things. So okay. So that if will say that a tissue unnatural growth of a tissue, that is we can say that is a tumor, and further it leads to the cancer. Okay, without it will not proper treatment. Nowadays, the lots of cancer. I don't know that whether the medical science is that growth due to the growth of medical science and awareness among the people. That cancer detection is more, or our lifestyle leads to the cancer detection more. I don't know. So that we have to calculate that so many people are working on these particular things. Whether that my point is whether why the cancer patients is number of cancer patients is increasing, that whether it is due to our lifestyle or due to that medical that growth of medical growth and awareness among the people, because people are going to the hospital regularly for the checkup, then detection of something else. Okay, that is going on, but it is not actually, we cannot say that whether it is. So at same time there is no cancer patient, but whether it is medical science, due to the medical science it is happening, and maybe it is a discussion part. Okay, the carcinogenicity means it is the that cancer causing factors. Some chemicals are there. If we go inside our body, then it will trigger that particular tissue for growth, and growth means unnatural growth. So that's why this is an important area. So be careful when you're dealing with the chemistry. Okay. Next, storage and handling of chemicals. Storage and handling, it is, I told you several times, like the sodium I told you inside the kerosene. So the incompatibility of chemicals. Okay, random storage, alphabetical storage, categorical storage. So what type of a storage procedure you will see, that is incompatibility with acetic acid, incompatibility with chromic acid, nitric acid, hydroxyl compounds, ethylene, glycol, perchloric acid, peroxides, permanganates. Incompatibility with. So you cannot that keep the acetic acid along with this. There is no compatibility. Incompatibility, right? Acetylene, chlorine, bromine, copper, fluorine, silver, mercury, you cannot keep with them. You have to keep away. So being a chemical analyst, you should have understand the things where you have to keep which chemical, where we have not keep to. This is the compatibility. Acetic acid should not keep with these particular things. If we come to the aniline, so nitric acid, hydrogen peroxide should not keep with these things. aniline somewhere else, nitric acid, hydrogen acid somewhere else. You cannot store in a particular area. Okay. So if you see, it's like that. Potassium permanganate, glycerol, ethylene glycol, benzaldehyde, sulfuric acid, you cannot keep. Okay. So these are the things. So handling of chemicals, then handling chemicals means you have properly leveled that what I told you. When you are keeping, actually we are not using the whole chemical. Suppose you have to take that is your 5 liter of hydrochloric concentrated hydrochloric acid is there, whose concentration is 95 percentage. So it is strongly high. So that's why you cannot keep. We cannot that bring every time the that hydrochloric acid particular from that container. So we have to just separate out few amount, we have to keep in another container. Okay. So when you are doing this one, you have to properly level that one. Concentrated hydrochloric acid HCl in a big manner, big, that alphabet should be there. Okay. That's the handling. So these are the things you have to that you have to understand that. Okay. Now the thing is transport of bulk chemicals. Okay, this is another things. How will you transport the chemicals, bulk chemicals? That is also important part. Okay, so what container will we have to use? Then safe handling of glasswares. So glassware, as the the sharpened things are there, and also that that hot glasswares as well as normal glasswares are equal in that is people come to the your optical nerve, and by seeing both are there is no changes. So that's why you should be careful, and glassware should be properly cleaned, and with that one. Okay. So things that all the precaution steps are there before doing any kind of experiment. This glasswares, as you are doing all the experiments through the glasswares, so that is maybe it is a conical flask, maybe beaker, maybe test tube, maybe what is that pipetting rod, maybe burette, so whatever maybe. So that should be properly cleaned and rinsed with the proper chemicals. Okay. So that is the most important thing. It is written over there. Okay, now the company equipment and electrical safety. That is another important equipment and electrical safety. I told you several times. So faulty electrical that is equipment may that you may raise the shock and all the things. Okay, so that should be, you should carefully handle these things. Okay. Uh, Now the thing is that, okay, emergency procedures. So if it chemical bonds, you should wash your hand first. If it is chemical bonds, see, if it is chemical bond, don't think that is my hand has bonds with the chemical, so I'm unable to. So you have to wash it immediately. Wash it immediately. Any chemical fall on that, your on hand or anything, you wash it properly. You have to through the raw water. That a normal tap water, you have to wash your hand immediately. You have to wash. That is the first point. All of you have to remember. The first step, such a situation, is to remove the opening agent at the earliest. Removal of containing contaminated clothes, longer they stay, greater the damage. Remove whatever things that you have to check it out after that. Okay. So thermal bonds. Thermal bonds means you have to cool it immediately. Cut and wounds. So first at first, you have to use that one. Ingestion of chemicals, this is another one important point. If corrosive materials is confined to mouth only, then repeated mouthwash is probably the best late. Okay. So inhalation of gases and vapors, move the victim immediately to the fresh air. That is essential part. You have to come out from that. Okay, these are the what are the things you have to do. So many things are there. Okay. So mostly this unit is over, and thing is that you have to go through it. Okay. And so tomorrow, today itself or tomorrow, I'll share all of your that is materials. Then with also that some numerical areas with solutions properly. Okay, chemical kinetics and all the things I'll supply with you all. So wish you all the best, and thank you very much.
Thank you, sir.
So be touch with that your what is that WhatsApp group. Any doubt, anything else, you can share with me. Okay, thank you very much.
Okay, sir. Okay.